We are at DesignCon2020 in Santa Clara, and Greg AC is going to tell us about using a sampling scope versus using a real-time scope. And what we're looking at here is a PAM4 signal.
If you look in the industry right now, you have two different types of scopes. You have the sampling scope, and the sampling scope's been for anything Ethernet related, it's always been kind of the gold standard of measurements. And so recently, the real-time scopes themselves have added a lot of bandwidth to get to 100 gigahertz plus. And so now a lot of customers wonder, well, if I do that same measurement on a real-time scope, how does it compare? Because I have the gold standard, which is the DCA, but then I also have the choice of the real-time scope. And so what we're showing here is that when you're looking at your measurements, if you measure on the real-time or on the DCA, you're going to get the absolute gold standard measurement. If you measure on a real-time scope, you're going to be a few percentage points, about 3% worse, but very close. But then the advantage of the real-time scope is you're able to do your debug. So, you know, what we wanted to show here is absolute best measurement, DCA. If you want to do some debug, but you want to get really close as far as the measurement, that's where the real-time scope sits in and is the perfect solution for you. So we're showing both at extremely high speeds at 112 gigabits per second.
Okay, and for those who aren't familiar with a real-time scope versus a sampling scope, this sampling scope, what it actually does is it takes many signals and overlays them, and it actually samples at a relatively slow rate, but takes many samples and then overlays these signals on top of each other, and that gives you the eye diagram. Over here, the real-time scope is actually taking a waveform one sample at a time in a serial pattern, as where this is more random, and then it builds the waveform. This will take many waveforms, but does them serially across and takes samples and then overlays them to get the eye diagram.
Yep, and to get nerdy on you, so this one samples at about 256 kilosamples per second.
Kilosamples.
That's kilo. And so
kilosamples, and yet we're doing gigabits.
And you're doing, exactly. Yep. You're doing 100 gigabits on here. This one over here samples at 256 gigasamples per second. And so if you come from real-time scope world, you're going to make fun of their sampling rate over here because you're like, I don't even know how 256 kilosamples can even work. But you're exactly right. It works because you're sampling very tightly aligned, building those samples on top of each other, and you're able to get these real-time eyes that are extremely low noise out of the sampling scope.